All right, so we are going to talk about area and volume day 5 notes. On your note sheet, it talks about volume with the disk method. And we talked about last class period and maybe the one before about slicing a figure into pieces that have a known cross-section. And as long as we knew that there was an area formula for that cross-section, we did area times thickness. So on this, we're going to do something using a revolving sort of motion. And so when you look down at these figures that are created, we have a region that's an area of some sort here that we are revolving around the x-axis in this case, but it could be any axis of revolution. And so if you look at the slice of this, if you took a slice out of this, it would be a circular slice. And so everything that we're going to do today with revolutions is going to deal with area of a circle, which you know as pi r squared. So as long as we can find the radius, which in the case of this figure is going to be this length right here of the function itself against that x-axis. So if I remember back to your past years where you've learned volume of a cylinder, you learned that it had the big B, which was area of the base times height, which was any general volume. You then also put it a little further into realizing that the base was a circle, and so you did pi r squared times height. And so when we're talking about our volume of our disk, we're going to be dealing with our pi times our r squared times our thickness. And then we come down here to, let's not worry about this right now, but let's talk about this exact volume can be found if we can get one representative disk volume and then use the integral. We will get the exact volume of the object. So I'm going to go ahead and put the pi from the pi r squared out in front because he's a constant and I can do that. I also will need to figure out what the radius of this figure will be generally and what the thickness will be. And so if we are considering the figure above, and I'm going to label some values, we'll call this A and this out here B. We are going to start gathering at A and end at B, and we're going to have to figure out what the radius of the figure is. And then the thickness, if you look at this rectangle up here, has a delta x, which we have learned down here in the integral is a dx. And according to our graph up here, the radius of this disk that's happening here is going to be the same as my function there. So what goes here in this case would be our f of x, and that would be the exact volume of the object. So if we're talking about horizontal disks, or horizontal axis, with disks, we're going to be dealing in terms of x. So our interval will go from a to b of whatever our function of x is, squared, and thickness dx. If we're dealing with vertical axis of revolution, I'm going to call it c and d. Those will be y values. And my function will be in terms of y, and my dy will indicate that as well. So sometimes, though, they aren't solid things. They might have a hole in them. And so you have to consider that sometimes we're going to have an outer radius and an inner radius that has to be subtracted out because of a hole in something. These are called washers. If you think about something in your garage, the difference between a washer and a disc. Sometimes I like to think of a disc as a frisbee and a washer as make sure that you realize it's got a hole in it, maybe even like a donut. A washer could be like a donut. So our volume with horizontal washers is still going to be a pi r squared idea, but we need the big radius minus the little radius. So we're still going to go from A to B. And so our outer radius squared minus our inner radius squared is going to take care of that subtracting out of the whole part of it. If we have a vertical axis, everything will be in terms of y. So we'll call our outer radius r of y and our inner radius little r of y and dy. I think some keys to remember in either the disc or the washer method. So things to remember are that in the disc or washer method, if we're talking about the representative rectangle that we're going to draw, it's always perpendicular to that axis of revolution. And if our rectangle is vertical direction, if it goes this direction, then we were working in x's. And if it goes this direction, we will be working in y's. So let's try some. Okay, onto the back of your sheet, you should have find the volume of a solid formed by revolving the region bounded by the graphs of the given equations. Y equals 9 minus x squared, x equals 0, and y equals 0, and we are going to go around that x-axis. So getting the sketch is important. Y equals 9 minus x squared should be a parabola, upside down, up 9 units. X equals 0 is this y-axis, and y equals 0 is the x-axis. So the part that's going to be bounded is the part in that first quadrant between 0 and 3. And so we are going to revolve this region around that x-axis. So if we're trying to visualize what was going on here, it would kind of look like a dome. Kind of like a dome. As you think about rotating this around, okay, that solid figure would be formed. So if you were looking from this direction toward it, it would look circular, dome-like. All right. So if we have, like the other page said, if we have a representative rectangle that is going to be vertical, that means that we're talking in terms of x because of this delta x. So there's 4 things that I do when I'm thinking about this. The first thing I do is that I sketch the region that we're talking about. The second thing that I do is I decide whether we're dx or dy. The third thing that I do is decide if I have a hole or not. So if we're disc or washer. And then finally I set up the integral. So our volume, we know since we're revolving, is going to involve the pi r squared always. We decided over here on our rectangle that the representative rectangle was vertical, meaning that we are in terms of x. And we decide whether there's a hole in this, whether it's a disc or a washer. And so I like to go over here and think about my axis of revolution, and I see that my region is sitting all the time on that axis of revolution, meaning there's no hole. So we're just going to deal with one radius value, which will be the value of that height there. We're going to start at 0 and end at 3, left-hand side to right-hand side. And then our radius is going to be our function, 9 minus x squared. If you want to think about it as upper minus lower, it would be 9 minus x squared minus 0. So if we go to our calculator, which I'm not doing at this point, but if you go to your calculator, you could use Math 9 and get your answer. And you have a choice. You can leave it in terms of something pi or actually multiply by the pi. But don't forget to multiply by the pi. All right, let's set up a new one. So I still have the same region. And I still have between 0 and 3. I still have a horizontal axis, which means we are in terms of x again, because I want that rectangle to be perpendicular to my axis of revolution. So I've decided with my sketch, I've done number 1. I've now decided, since I am a horizontal axis of revolution, that I'm with respect to x. I still am 0 to 3. Now I need to decide whether we're disk or washer. And when I'm looking at this, I notice that we have all of this region down here where there's a hole. So we have to consider a big R, which is always going to be the length from the outer edge to the axis, always going in the same direction as the rectangle, and the little r, which is going to be from the edge of the hole to the axis of revolution. So our big R should be the function upper minus lower, again, big R squared, minus little r squared, which would be 0 minus -2. So I'm going to go ahead and say just 2 squared. So we have a big R squared and a little r squared. On to the next one. All right, we're finding the volume again this time, but this time we are going around the y-axis, same region, around the y-axis. Rectangle must be perpendicular to the axis of revolution. This means we're in terms of y. So we're going to have a pi involved here because of the revolution idea and the disk idea. And we're going to have to fill in the pieces here. We have to decide whether there's a hole or not. So if I look at the axis of revolution of my region, I am sitting on it the entire time, meaning there's no hole. I'm in terms of y. So I need to figure out what the function of y is. So we go from 0 to 9 in this case, y values. And we need right minus left. I cannot write 9 minus x squared because I need a function of y in here. So I'm going to have to solve this for x equals. So I get y minus 9, change the sign on it, and square root both sides, and that gets me plus or minus the square root of negative y minus 9 is equal to x. We're only interested in the positive version. So right hand side would be square root of negative y minus 9 minus left, if you want to say that, minus 0. And don't forget the pi. We're going around the line x equals -2 in this one. Same region, same representative rectangle as part C. This time we got a hole in this, though, so we need big R and little r. So our volume is going to be pi from 0 to 9 of big R squared, which has to be in terms of y. So we've got square root of negative y minus 9 minus a -2, all squared, run out of space, minus the little r squared, which would be right hand minus left, which would be 0 minus -2 squared, and then that's all in terms of y, and you put it in your calculator. So quickly, we'll have to work this one together, but your homework will be on page 463, section 7.2, and you're going to work part of them on the calculator and part of them not.
This message was brought to you by the letter B, where boys rule and girls rule.
Kumbaya!